This is not good. Okay. The F1 scores are all lesser than our other model that we trained a little while ago. Let's try XGboost and let's put 515 here. Okay, and let's train it. So guys, I feel LightGBM did not perform very well. Decision tree is the winner at this moment, right? So let's see if the XGboost can beat the performance metrics, performance values of decision tree. Okay. But in the meantime, while the model has been trained, we can look at the bar chart. So you see we have some nice bar charts that is comparing the classes 0 and 1. You see in V11, I actually like this. We have some clear difference, right? You see the bar of class 0 is a bit below than the bar of class 1, right? So this is probably an important variable that can draw some boundary between class 0 and 1, right? Similarly, V12, we see yeah, we see some good difference, right, between the bodies of bar charts, right? So sometimes these bar charts give some good idea, I mean, about the signal a variable or feature can give to the target variable, right? For example, V26 might not be a very good feature or variable because the bar charts, we see both the bar charts bodies are almost at the same level, right? There are not much information they are probably giving to the model. Okay. And we also have feature statistics here. We can see like minimum, maximum, median values of each feature, right? We have mean, standard deviation, Q1, Q2, Q3. Let's see if okay, the training is still going on for the XGboost classifier that we selected. Feature statistics here. Okay, so we just went over that. So you see we have standard deviation. Many feature doesn't have much standard deviation, right? So if a feature doesn't have much variation or much in standard deviation, you probably can drop that feature, right? Because you see why we would like to drop features, because some features might be very noisy, right, and doesn't give much signal to your target variable. Also, there are some features that those are probably useless, right? And if you delete those, your data set will be smaller and model would be much more faster. In this platform, we have another option, top 20 features. So by default, it gives us what are the top 20 features, right? That can kind of like that can contribute more to the decision of fraudulent versus non-fraudulent behavior, right? So V24, V1, V23. So these are all top features. Maybe you can have a look at V24 bar chart. Yeah, that's interesting. In V24 bar chart, we see, so we have a large range, right? For 0 class, from starting from here to there, and we have a smaller bar chart region for the class of 1, right? So V24, V23. So according to the analysis, it is also a high, one of the top features. And then V1 is one of the top features, right? Okay. So we are still waiting for the model training to be finished. Okay, so our model training has been done, and we see. Okay, now I am kind of happy to see all our F1 scores are above 93, 94, 95. We have a F1 score of 1 and 0.84. We have precision, both classes are showing good precision, 0.911. Recall is a bit less at this moment for, I think, for the class of 1, right? But still, given all the values between decision tree and XGboost, I would go with XGboost. I could also train random forest, logistic regression, support vector machine, right? But for now, let's deploy this model. And on this platform, model deployment is very easy. It's one click, so you can click on select, and the model can be deployed easily. Okay, so you see we are on prediction screen now. Basically, this is inference screen, right? And we can hit predict. By default, it uses some mean value for this variable, but you can kind of put different values here, right? Based on I mean, what are the new transactions? So based on any new transaction, you can put different values, amount, and then hit predict, and you see it predicts 0 or 1. You can save this model, credit fraud model, right? You can save it. So model saved as credit fraud model. Let's go there. So you see our credit fraud model has been saved and deployed, right? We have REST API endpoint. It is giving you some idea how to call the REST API endpoint. We have curl command already here. We have shareable link, so you can share this model with your friends or whoever you want to share it with, right? Let me run the curl command. So I use a website, recbean.com. So here I can run the curl command. Okay. 1 second. Okay. Okay, you see I ran the curl command and result came as 0. I just copied and pasted. Let me try to, so I know we can, I know this data is from a class of 1. So let's see if the model can predict this data or not. Okay. Yeah. Curl command, run it. Yeah, so the model could predict these data, which I took from the samples, right? In the original data set, and I see the model could predict it as 1, right? So you can also hit the predict and then fill up all these values, right? And then hit predict button. It will predict either 0 or 1 depending on your values, right? Oh, sorry. Yeah, you can put different values. Basically, you need to fill all the values, right? And then hit the predict button, and it will give you the class that it is predicting from the model. Okay. And now finally I want to talk about shareable link here. So we can give this link to anybody to, let's say, train a model, and if you want your friends to use the model, right, without logging in to this platform. Let me log out. It should still work. So you see, now I'm not logged in, right? So, but since I have the shareable link, so I hit on it and I can still see the inference interface. I can hit predict, right? I can also fill in with different values and predict, right? Okay. So, okay, guys. So I think we covered today about the data exploration and training a supervised binary classification model without writing a single line of code, using a free automated machine learning model development platform. Thank you for watching.